Hi everyone, Mr. Skelton here. We are back at it, lesson 7 in unit 5, and today we're going to be talking about solving equations with rational exponents. So we're solving here, so I just wrote down, we're trying to find out what x is, and we're going to be using inverse operations. Opposite of add is subtract, divide, multiply, etc. Rational exponents. Let's talk about rational exponents. Rational exponents. Rational means fraction. Exponents are exponents. So we're talking about something like x to the 2/3, where we have fractions as our exponents. That's what we're going to be dealing with today. Okay? Let's jump right into it. So, in our last lesson, we talked about solving radicals, right? We had something like this, and I told you that we need to isolate the square root symbol before we can square both sides. Well, what we want to try to do here is we want to isolate the exponent. The exponent is the base with the power. So if you have something like 3 out in front here, multiplied, don't distribute. We're not distributing here. All right, we want to try to isolate this parentheses, this quantity of x minus 2 to the 3/4, so that we can manipulate the exponent here in a minute. So we're going to get x minus 2, so it's important to isolate the exponent. The exponent is the base with the power. Okay, so that's like having x to the 2/3. We don't want anything out in front of the x, or if we had something like plus 3 here, we want to subtract the 3 and divide by whatever. So we get this to the 3/4 equaling 8. Okay, now in your experience in math, how have we gotten rid of a fraction? We have always multiplied by the reciprocal, correct? So we're going to do this, and whatever you do to one side, you have to do to the other, and that is an exponent there, or a power of 4/3. So what happens here is real nice, because watch what happens. What's 3 times 4? 12. What's 4 times 3? 12. So 12 over 12 makes 1, and what's x to the x minus 2 to the 1 power? Because that's really what we get. We get x minus 2 to the first power, which is x minus 2. So that's how we kind of get rid of that rational exponent. Now, over here, we did a lesson a couple back where we can write this in radical form. So what we want to do once we get that is we want to convert to radical form. Now, you could take your calculator out right now, okay, and I'm going to show you how to do this on your calculator. You have 8 to the 4/3 power. Well, you can go 8, caret button, parenthesis, 4 divided by 3, and hit equals, and it's going to spit out 16 to you. But I want to show you how to do this by hand, all right? So if we convert this to radical form, remember this is the cube root of 8 to the 4th power. So really what we have is x minus 2 equals the cube root of 8, right, is 2. So we really have 2 to the 4th power. 2 to the 4th power is 16. We add 2 to both sides, and we get x equals 18. You can see the answer right there, but just making sure that we did it. Now, we're going to come back to this problem here in a little bit, and I'll show you why on the next. I believe it's the next problem. Okay, so on this one here, when we look at this, we see that we have nothing out in front of the x plus 5. There's nothing added outside of the quantity, so it's already isolated. And what we're going to do here is we're going to multiply by 3 over 2. So this is really 3 over 2. So we're left with x plus 5 equals. Now, here's where we have to be careful. A lot of students are going to make mistakes here. What does this get converted into? That gets converted into the square root of 4 to the 3rd. Now, so what did we basically do? We basically square rooted both sides. Take your brain back to this. If I had x squared equals 4, right, and I square root both sides, that gives me x equals plus or minus 2. Well, I'm square rooting 4 here. So what happens is we get x plus 5 equals plus or minus 2 to the 3rd power. So I get plus or minus 2 to the 3rd power, which is going to be plus or minus 8, right? 2 to the 3rd power is 8. So watch what happens. I really get x plus 5 equals positive 8, and x plus 5 equals negative 8. So I subtract 5, I get x equals 3, and I subtract 5, and I subtract 5, get x equals negative 13. Okay? So any time that when you multiply by the reciprocal, and here's what you need to remember, and the bottom number is even, you're going to have to plus and minus. So whether it's a 2 here or a 4 here or whatever, you're going to have to make it plus or minus. We don't have to make it plus or minus on number 1 because I took the cube root, and that's just going to yield a positive 2. There's no way I can get negative 2 out of the cube. Like if I take the cube root of 8, right? There's no way that's going to equal anything other than 2. But just think about it. If I said negative 2, that would give you negative 8. So when it's odd like this, there's no plus or minus because it's just going to yield one answer. But as soon as you take an even root, like when I take the square root of 4 because I'm solving, just like we did, you know, back in our quadratic days, you're going to have a plus or minus, okay? So keep that in mind as we go forward. All right, let's take a look at one like this. So this is set up. Now we're just going to be doing some problems that are just set up a little bit differently so you can kind of get adjusted to what you may see on the homework. So on here, the first thing you want to do is add this to the other side. So 3x plus 2 to the 1/2 equals 2x plus 7. Just added this whole thing to the other side to the 1/2. Okay? Now, what are we going to do to both sides? We're going to times this by 2 over 1. We're going to times this by 2 over 1. Right? Whatever you do to one side, you have to do to the other. So these basically just make 1. And so you're just left with 3x plus 2 equals 2x plus 7. And you're just solving this for x. So you're going to get 3x minus 2x, which is x, equals 5. Done. All right? On this side here, let's take a look. So here's a situation where now we have square root symbol. So this is kind of review. All right? We just get some different answers than what maybe you're used to seeing. So I'm going to add 5 to both sides. So this is really a continuation of lesson, I believe it was, what is this, lesson 7? So this is a continuation of lesson 6 where we had square roots, right? So you got 3x plus 13 underneath the radical sign, and you have x plus 5. So how do we get rid of a square root sign? We square both sides. Now watch what happens. Squaring a square root cancels itself out. Now we have x plus 5 squared. Now remember, that's this. And so we get 3x plus 13 equals x squared plus 10x plus 25. Remember, the shortcut is to add the two numbers. That's your middle term, times them together. That's your last term. And now we solve this for x. This is going to turn into a quadratic. So I'm going to minus the 3x and minus the 13. I'm going to get 0 equals x squared plus 7x plus 12. And then we're going to factor this. We're going to solve by factoring. Factoring's not going away. Quadratic's not going away. X plus 4, x plus 3, right? 4 times 3, 12. 4 plus 3, 7 equal to 0. And so you get x equals negative 4 and x equals negative 3. Okay? Why don't you go ahead and try slide 5 on your own. Very similar to what you just did. Hit pause. Come back up and check if you can. All right. Now, you know you have the answer right here. And some of you, if you didn't have the answer, you may just use some number sense and go, what could go in here, which if I go 3 plus 6 and get 9, the square root of 9 is just 3, so it's just 3. You're right. This is a pretty basic one, but again, showing you this so that you can get used to seeing that when you square a square root, cancels out. X plus 6 equals x squared minus the x minus the 6 from both sides. So you get 0 equals x squared minus x minus 6. And then we can factor this into, let's see here. That's going to give me x plus, or x minus 3, sorry, and x plus 2, right? Negative 3 times positive 2 is negative 6. Negative 3 plus 2 is negative 1. Now, your brain's probably starting to move a little bit here, and you're thinking, well, wait a minute. I'm supposed to get two answers here. I got x equals 3, and I got x equals negative 2, right? And then you look at the answer, and it's just one of these. Well, plug these back in. 3 plus 6, 9. Square root of 9, 3. Plug in a negative 2. 6 plus negative 2 would be positive 4. Is the square root of positive 4 equal to a negative 2? It's not. So this is an extraneous solution, so we're not going to use that. Okay? All right, last one here is 6, and so we would minus 3 from both sides because we need to isolate the radical symbol. So we have 5x minus 1 equals x minus 3. Okay? and then we're going to square both sides. And squaring the square root, you're left with 5x minus 1 equals x minus 3 twice. And so you get 5x minus 1 equals x squared minus 6x plus 9 minus the 5x and add 1 minus the 5x and add 1. So I get 0 equals x squared minus 11x plus 10. And so I'm going to factor this into x minus 10 and x minus 1 equals 0. Then I get x equals 10 and x equals 1. Make sure you check your answers. And you can see if you plug in a 10 here, 50. Did I do that right? Yep, I did 50. Minus 1 is 49. Square root of 49 is 7 plus 3 is 10. If I plug in a 1, 5 times 1 is 5 minus 5 times 1 is 5, minus 1 is 4. The square root of 4 is 2. 2 plus 3 is 5, not 1. So 1 is extraneous, doesn't work. 10's our winner. All right, the last one here, number 7 is definitely a challenge. I'm going to get it started, and then I'll let you kind of finish it and see if you can come up with 1 or negative 1 here. If you notice here, we can't add these together because they're not like radicals, so there's nothing to really isolate. So what you're going to do is you're going to square both sides. Now on the right side, you're just going to get the 5x plus 3. On this side, and this is where I'm going to let you kind of go nuts here, this is itself twice. And so what I want you to do is see if you can finish this problem. I'll give you a hint. You got to FOIL. All right? So you got to FOIL this out and then work it down and see if you can get that. If you can't, we can go over it in class. If you can, you're rocking and rolling. All right? So look forward to seeing you in class. If you have questions, and I expect some questions on 7, so I have no problem going over that or any other questions you may have, and I'll see you in class.